Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Hannes Mühleisen about DuckDB, an in-process embedded database engine for columnar analytics. So Hannes, can you start by introducing yourself?
Thanks for having me. I'm really happy to be here. My name is Hannes Mühleisen, indeed. I am the co-founder and CEO of DuckDB Labs, a small artisanal data management systems company in Amsterdam, the Netherlands. I am also a senior researcher at the Database Architectures Group of the CWI. The CWI is the National Research Center for Computer Science and Mathematics in the Netherlands. It's mostly famous for inventing Python, or being the place where Python was invented. Very different things. Yeah, so I spent like the last 10 years of my life working on data management systems, and recently, in the last 3 or 4 years, on the system called DuckDB. And really excited to tell you more about that.
And do you remember how you first got involved in the area of data and what it is about that space that has drawn your attention?
Yeah, it's really fascinating because, cast your mind back to the year, 1998 or something like that. I was, messing around with PHP, like many kids back then. And there was something called MySQL. I learned that you had to talk to this MySQL in order to do something with data. And it was really all very fussy. And I wanted to write some sort of application, and I had to write SQL queries. And obviously, I didn't know anything about PHP. I didn't know anything about SQL. So it was really a mess. And you grow as a user of something like MySQL. And then when I went to study computer science, I did a bit of a detour in distributed systems. I really learned to appreciate the sort of the field of databases as a very no bullshit zone, I like to call it, because you have very clear metrics of who's right and who is wrong. I mean, obviously, as now I'm in the field for longer, I've also realized that there's more to this than I maybe initially thought. But I still appreciate this, focus on metrics, on benchmarks, on measurable effects that is really prevalent in the community. I feel it makes it a very scientific discipline of practical computer science specifically. After getting my PhD, I joined this database lab, the Database Architectures Group here in Amsterdam. Yeah, and I've been here ever since.
And as you mentioned, for the past few years, you've been working on this DuckDB project, which you have now built a business around. I'm wondering if you can just give a bit of an overview about what it is that you've built there and some of the story behind how it came to be, why you thought it was a project that was worth spending time on, and sort of some of the areas of focus that you have for the DuckDB platform.
Okay, so DuckDB in-process SQL data management system and query engine, specifically for analytical data management. So OLAP, it's called. Not sure the term is familiar to the listeners, but data management systems come in many flavors, not one size fits all. And you have this traditional divide between systems that are built for transactions and systems that are built for analytics. DuckDB is built for analytics, which means, it can do large aggregations, large joins, these kind of things. Big data, some people like to call it. So DuckDB is special because it's in process, which means it doesn't actually run as a separate database server like you know from literally everything else, but it runs inside, whatever application you want to run inside of, typically Python, for example. In that regard, it's very similar to SQLite, the world's most widely deployed database system. But again, SQLite is, while being an excellent system, is made for transactional use cases, and DuckDB is focusing very hard on these analytical use cases with, high throughput query processing. And this is kind of funny because the background story there was that we literally talk to people, which is very rare for computer scientists. We like to talk to the computers, but maybe not so much to the people. We talked to statisticians, and they complained to us that they wanted to do this analysis and it didn't work, and they wanted to see whether we could do something about it. And at the time, we were working on a different data management system. It was also built, the research group at CWI, and we were working on integrations with R, the R environment for statistical programming. There was a couple of iterations. This took years and years of trying to figure out what the architecture for data management for like a new data management system could be that would support these use cases. And these use cases didn't, for example, we're always like, okay, there's always a single user. They don't really want to spend time on setting up stuff. They don't want to spend time on moving data around, importing, exporting. This should all just work. And but at the same time, of course, state-of-the-art data processing capabilities were required to deal with the large data sets. So that kind of gave rise to this concept that, hey, we need to make something that runs in process, that doesn't require us to do separate setups for servers and things like that. And we need to make something that is actually fast. So, we're in a good position as an academic research lab in the field of high-performance data management systems. Kind of had an idea what the architecture of the system should be, but what is new, and it was still new, I don't think there's anything else out there that does this in-process OLAP, has this in-process OLAP focus. And there's also nothing else that is custom built for this specific use case. And it's quite a funky world to be in, to be honest. If you're trying to run in somebody else's process, you have to deal with a lot of special things like, they overwrote a signal handler, therefore you cannot use a signal handler anymore, things like that. But so that's kind of how it came along. And one of the cool things about CWI, the institute that I still work at, is that they kind of leave you alone. So you have very nice offices and they treat us well. But there's this understanding that some things just take time, that this is, still worthwhile to do. We were able to basically disappear for a couple of years and start building our data management system from scratch, which I can't imagine other places that would have allowed us to do this.
It's definitely great to be able to be given that freedom, and it's always interesting to see what people will come up with given the time and space to really deeply understand a problem space.
Mm-hmm.
One of the interesting aspects of the project is obviously the name. So I'm wondering if you can talk to where that inspiration came from and why it's called DuckDB.
I live in Amsterdam and we live on a ship. And we're constantly surrounded with waterfowl. So at some point, I thought it was a great idea to have a duck as a pet. The duck was called Wilbur. I got him when he was a little duckling, and it's very cute because he was running around my kitchen all day long. Eventually, he grew up and he learned to swim and to fly and all these things. It was very cute. At some point, he just left, which is fair enough, I guess, for a teenage duck. But so DuckDB obviously is named after little Wilbur. We also think that database systems tend to have completely ridiculous names. So we are in very good tradition there. Plus, they tend to have names like shaving cream, like super performance power, And I think this is just completely ridiculous and also non-Googleable, whereas DuckDB, hear it once, you can find it again. It's not a problem. So we're quite happy. And of course, the logo designs itself, which is great.
Absolutely. When I first came across it, I just assumed it had something to do with duck typing and sort of being dynamic and adaptable, but...
No, it's literally ducks. And we have some post-hoc justification for the names because duck are versatile, right? They can swim, fly, and walk. Also quite resilient, they're hard to kill. So in that sense, it's a perfect role model for our data management system. We can do a lot of things and it's hard to kill. This is something that we've actually spent quite a lot of time on thinking about for DuckDB, is how to, for example, tolerate broken hardware. Because if you're one of these cloud guys, you run the hardware that your database runs on. Great. You control the entire environment. If you're going to be installed on everyone's laptop out there, which is what kind of DuckDB is aiming to, of course, to basically become something like SQLite, but then for analytical use cases. If you're on everyone's laptop, you're going to have thousands of broken machines that you're running on, right? So how can you actually deal with that? It's kind of a fascinating problem, and we're still working on that.
Absolutely. And I'm probably jumping ahead a little bit here, but one of the things that I've run into personally as far as broken hardware and database systems is that if you have just a large binary object and some portion of the hard disk gets corrupted, then the entire database becomes unusable. And because of the fact that in the situation that I'm thinking of, it was just one single binary blob and that there was no sort of separation of individual files for individual records. So I'm curious how that manifests in DuckDB, because I know that with SQLite, at least, it is just a binary blob and you have one database file that is the whole database. So I'm curious how that manifests in terms of being resilient to broken hardware, but still being portable and adaptable.
Yeah, that's a very good question. So we did adapt the single file database because in our interactions with the people, we have learned that they love to email databases around. And I'm not making this up. Because of this user requirement, we decided to also have a single file data format, which basically means all the tables that you store in a specific DuckDB database, they're all in one file. The way it's resilient to corruption is that the file is separated into blocks and each block has a checksum. And so we can kind of early detect that something is wrong, and you can also find out which blocks are still valid, for example, without too much trouble. This is something that SQLite also has, but they don't have a checksum. They have the blocks in the file, like a logical blocks within a file, but we have that too. But we have a checksum on top of it, which means that we know if a block is corrupt, and we will say, no, this hard disk is no longer to be trusted, because that's kind of what you have to do, right? This is also a bit of a departure from traditional systems design where we have to start distrusting the hardware. We wrote a research paper some years ago about this topic for people who are interested, is how would you design data management system when you cannot trust hardware? And again, it's not like some weird out there idea that we came up with on a Friday afternoon in our in our nice research institute, but it's something that we actually experienced. There was this one guy on like a 32-bit Brazilian laptop with Windows that just had broken RAM some years ago. And he would keep sending us these bug reports that made no sense. And it takes a while till you tell somebody, look, your RAM is broken. Throw your computer away. This is difficult to tell somebody on a GitHub issue. So this is when we decided, no. Now we're going to defend against this kind of thing, But this is indeed a bit of a far out discussion already.
That's dedication. Yeah. The specific database that I was dealing with was actually a ZOP database, which is just a sequence of pickle files that have some vague correlation between the individual records, but very opaque or completely non-existent documentation about how to repair corruption in such a thing.
Python pickles, that's not pretty. No, I agree. I mean, for SQLite, I've actually written a third-party reader for this format that they use, because it's the way I understand things, is to write a parser for it. So I've written this SQLite parser, and the format is actually, it's like 200-300 lines of C code to parse this. It's not crazy. One of the reasons why the SQLite's own code for this is so much bigger, because there's a lot of error checking it for airplane purposes.
And so given this similarity in terms of the ways that SQLite and DuckDB are used of being in process and potentially being very ubiquitous, it can be easy to, maybe confuse the use cases between them. And so I'm wondering what you see as some useful heuristics for deciding when to use which format, and maybe some of the ways that they're able to interoperate, either in terms of just application design or being able to convert or import back and forth between them.
Yeah. So it comes back to this OLTP versus OLAP discussion. If you have transactional use cases, SQLite is the obvious choice. And what is a transactional use case? It is when your queries and your changes to the data are focused on few rows at a time, right? So you're updating a single row, you're tracking some sort of order or user data or whatever. So you're updating. The query is usually update users set email is new thing where ID is 42, right? This is a very typical OLTP query. Yeah, we call this a point query because it points to a single row. And for this kind of stuff, SQLite is really excellent. On the other hand, have OLAP style queries that look like select group name, comma, average, price from table with 1 billion records. Then you have more an OLAP style use case. And for that, DuckDB would be the far superior choice because of its internals. It's more a columnar design. We can talk about that later, I guess. But it's sometimes funny because, as you said, what we've copied a lot of good ideas from SQLite in terms of packaging, in terms of how it behaves. It's just a library. You do pip install DuckDB and you have it. But okay, a lot of stuff is pip installed X these days. But in our case, it really is just a module that is linked into the process and loaded. And what is very different, and I think SQLite users realize this, but for OLAP, it's pretty revolutionary that the OLAP system is suddenly wherever you want it to be, because traditionally, these things are kind of bound to the machines they live on. You have your Teradata somewhere in your company, and that's where the data lives in your data warehouse, or you have your Snowflake instance these days somewhere, and that's where your data lives. But you wouldn't ever dream of saying, hey, I have this software that I want to install on somebody's computer, and I kind of need to do some data wrangling, and it's actually quite serious. So let me just drop a DuckDB instance there, because you would just not be able to install a Teradata on every single one of your customers' computer. You would not be able to install a Spark, or you would be able, but you wouldn't want to install a Spark on every single one of your phones that run your app. It's not possible. But with DuckDB, you can just simply pull pretty serious data crunching capabilities inside wherever you want them to be. I think this is the kind of fundamental architectural difference that this enables, is that you can pull this query processing capability wherever you want. But yeah, to come back to your question, the heuristic is going to be, how do your queries look like? How do you interact with this data? And you also had this question about how could you possibly combine the two? And I can happily report that we've thought of this. We're going to soon release something we call the SQLite scanner, which is going to be a functionality so DuckDB can directly read SQLite databases as if it were local files. And the cool thing is we can do it faster than SQLite itself, because we parallelize the read. So it's like, and not only can we read this, we can also do it faster, which is kind of funny. Yeah, the other way around, if you wanted to read a DuckDB file from SQLite, I don't think that is super easy at the moment.
Well, I mean, it's kind of in keeping with the general flow of data in analytical systems anyway, where you have your transactional application database and data moves from there into your columnar analytical warehouse, and then from there to some other downstream system, but usually not in the reverse. So
yeah, this is true. And this is also, I think, why this is super interesting. This even works for SQLite while you run other queries on your SQLite, right? It doesn't really interfere. We're also working on some similar functionality for Postgres, where DuckDB can directly read Postgres' databases, because we also think that, too often big data is just, the same fairly small data copied a million times, because people have no other choice than to replicate everything from, the Postgres where they keep their operational stuff to whatever system they feel they need to use in order to do analytical queries, which, it's unfair to benchmark something like Postgres on TPCH. It's just not built for that, right? Yet people still do it, of course. I love it specifically when academics, in my field, propose some new OLAP architecture, and they just in the paper have a benchmark against Postgres, and you just think, like, come on, people, this is just mean, it's just, you don't do that. But still, I think the combo is more interesting, in my opinion, than the HTAP world. You also have these HTAP systems that attempt to fulfill both use cases, to be both a crack transactional system as well as being good at OLAP. I am not entirely convinced this is, the way forward either, because you're going to be forced to compromise somewhere. So I think having a bit of a closer bond between two systems that focus on, individual aspects of this, for example, something like Postgres or SQLite paired with something like DuckDB or something else, is probably a good idea.
In the other direction of being in the point where you're trying to decide, do I want to use DuckDB versus, some beefy data warehouse, whether it's a, cloud provider or something like a Vertica or a Teradata that you're running on premise, what are the deciding factors of when you might want to use one versus the other, or possibly in conjunction?
There's an interesting question with the conjunction. I'll come back to that. I think the traditional data warehouse is your obvious choice if you have, thousands of analysts hitting the same data all the time, because DuckDB is in process, right? So we don't do client server. which means you would have to replicate your data to all your analysts or have them all work on the same cloud box with all the data in order to, make use of DuckDB properly. I think for these use cases, you would be better off using something like Teradata or Snowflake. What I think is a bit underrated, though, is this capability of everybody being able to run their own thing. And I think as an analyst, you will not be allowed to just wildly create tables in your Teradata instance that are just like small variations of the giant fact table that sits there. Whereas this would be perfectly allowed if you just have your own DuckDB instance and you can do whatever you want on your local machine with it. What we see as a use case sometimes is that people use them in conjunction, which is quite clever, I think, where they say, okay, we're going to make an extract of our data warehouse for one particular analysis question. We're going to write that to a Parquet file, for example. And then we're going to give this to the analyst. And the analyst can, or the data scientist, whatever you want to call them, can then on their own, on their local machine, without interfering with anyone, without, producing extra costs on Amazon, whatever, they can then play with this data as much as they want using the standard SQL. You don't have to learn strange Python package syntax to do data analysis. You can just use normal SQL queries, and we have actually quite powerful SQL support. So this is really the same kind of SQL that you would run on something like Teradata. And then they can play and can explore and really can get a faster turnaround time for the analysis. And I think that's really a promising sort of concept. And because DuckDB natively reads Parquet files, you already have a data format to do so. But in general, I would say if you have 1,000 people that are supposed to do analysis on a data set that is central and doesn't change, you probably don't want to use DuckDB for that.
One of the ways that DuckDB is strongest is obviously for this in-process use case where you have a language environment, you have data that you're working with, you want to be able to take advantage of the acceleration and performance benefits of DuckDB. One of the ways I've seen that is in the Python ecosystem where maybe you have a pandas data frame and then you read that into a DuckDB file. You can use SQL to be able to perform some analysis on that and then be able to transform that back into a pandas data frame. And I know that there have also been some optimizations to be able to use the arrow format to make that a seamless or completely cost-free process. I'm wondering if you can just talk to some of the benefits that DuckDB provides over and above some of the capabilities that are present in these different language ecosystems, or some of the ways that you might want to use DuckDB to be agnostic to the language entirely.
We have, indeed, as you mentioned, we have integrations with many, many languages. I've kind of lost count at this point. But there are two languages, I would say, that are special, and this is Python and R. And that's because I think a lot of data analysis, data science workflows start in Python or R and end in Python or R. So this is why we spend some extra time with the integrations there. And so one of the things that is super powerful with DuckDB, if you're running in process, is that we can read the memory of the process we're running in. It's a very strange concept, but it's just, we're in the same address space, we can just look at things. And the internal layout of things like pandas or data frames in R is not really a secret. So you can just look at these things, right? And that's also something we've done in DuckDB. So indeed, as you said, you can import the data frame directly in a database file in DuckDB, but you actually don't need to, because we can run SQL queries directly on pandas and R data frames by simply saying, hey, query, instead of reading from the file, please scan, we call this a scan operator, scan this data frame. This is even zero copy for some data types, so we don't even copy anything. And because DuckDB is a streaming engine, it means that it doesn't actually materialize your data twice in memory just to query it. If you're just running a simple aggregation on top of 10 billion rows of a data frame, you will use constant memory for that, which is pretty cool. We also have this on the other side where you, in R and Python, if you have a query result from DuckDB, let's say you run a query from whichever source, you have a result that we can efficiently then transform again back into data frames in Python and R. Julia, as of this week, I believe. And this is also super powerful because, again, we are in the same process, which means in order to create a data frame, we can already set up all these in-memory structures, fill it with stuff, and then just hand over and say, hey, pandas, here's a data frame that now miraculously exists in memory. Please use it. And that totally works. What it allows you to do, for example, because it's so fast, because it doesn't have to go through a socket or something like that, allows you to quickly do an iteration over queries. You can look at some fixed point iteration if you wanted to, and just read a table from database, iterate, write it back, and just iterate. And that's not a problem at all. With Arrow, yes, indeed. Of course, we wanted to be good citizens in the ecosystem, and we've actually been working with Ultron Data on improving the integration between DuckDB and Arrow, and the same applies there. You can run SQL queries directly on Arrow structures, specifically on tables and record batches. We can also, again, export query results directly as Arrow batches, basically. So yeah, you can also, as I said, move this iteration through DuckDB on Arrow, and it just goes in an interesting circle. There was one interesting bug that we had there a couple of weeks ago that I'd like to talk about, because it's not something that you think about when you invent this kind of thing. So we have zero copy, yes, which means we can use memory that we see on the input of a query, like in the from part. We can use, for example, from an Arrow structure. We can use that and directly put it into our engine without copying it. Now, that's very powerful because, as I said, no copy, better performance. And now this can go all the way through the query engine without being copied, because for some queries, we just keep referencing the same memory pointer because, imagine we only do a projection on something, the column data that is not being touched. And now this goes all the way through the engine. It comes back into the result. We do another zero copy where this time we make a new Arrow structure that references DuckDB memory, okay? But we forgot to think about the fact that this memory that DuckDB thinks it's his own is actually not his own memory, but is something we borrowed from Arrow all the way back there. And now this can go in circles. So you end up having this circle of references to memory that is kind of arbitrarily long because you keep referencing the same memory. And now the question is, who calls free? And remember, you can only call free once because otherwise you crash. It's really like, okay, first of all, how do you keep it from being freed? Okay, that's usually not so crazy. And second of all, how do you free it up in it? Because in order to free this correctly, you have to circle back all this way through the multiple, recursive layers of DuckDB Arrow, DuckDB Arrow, DuckDB Arrow interactions. And this was kind of funny because it took our people and their people some time to figure this one out. But now it works. But you don't imagine this kind of problem because traditionally this problem didn't exist, like zero copy between the database and your application. What? But also something I want to mention there is that, yes, we have these special scanners for data frames and for Parquet files and for Arrow and for CSV files and for a bunch of things. For SQLite, I mentioned this. But you can also plug your own. DuckDB, we are kind of data communists in that sense that we treat all data sources equally. And our own table scan operator is actually just yet another one of these sort of zoo of table scans that we support. And you can bring your own as well. So these are all just functions, and you can have a user-defined function that is a table-producing user-defined function that reads whatever data you have in whichever format it may be and makes it look like a table. And then you can run whichever SQL query you want on it. And that's actually something that we've been doing quite a lot in our spin-off company, to work with people to build scanners for data that they have. For example, they might have a custom application that stores a lot of data internally. They want to add SQL support to that. Fine. We will be able to build one of these scan functions for them. And they have the exact same capabilities as their own scan functions, so they can do projection pushdown, they can do filter pushdown, they can do all these things, they can do parallel reads. And this is, I think, quite a unique capability in a data management system, that you have this sort of arbitrary sources of where the table data can come from. So today, for example, I was running some benchmarks and aggregates because I was working on that some time ago and I wanted to finally write a blog post up on it. And then, in this case, we're just running directly from Pandas. And it's actually as fast as running from our internal storage, which I think is pretty unique.
Yeah, it's definitely pretty amazing. And if I was more of a masochist and actually had free time, I would be interested in actually writing one of these plugins to be able to use DuckDB to scan a ZopeDB to be able to run analyses across that.
Yeah, exactly. I mean, that would be exactly one of these examples to say, if you have terabytes of ZopeDB lying around, you could write your own scan function and just treat them like SQL tables.
Yeah, in this case, it's about a 65 gigabyte Zope database file, which is enough of a pain to deal with on its own.
That sounds horrible, yes. I'm sorry.
Thankfully, we're in the finishing stages of making sure that nobody ever has to think about that again.
What is in these pickles, if I might ask?
So this is actually for the OpenCourseWare project from MIT, because that's where I work for my day job. And we have been using Plone as the content management system for that for a long time. And so it's 20 years worth of content data for publishing the OpenCourseWare site.
Oh, yeah. That's not something you want to lose either, isn't it?
Yeah.
Wow.
And we had a SAN failure where some of the drives failed and other ones got corrupted. And so, the middle portion of the 65 gigabyte pickle object was corrupted. And we had to spend about 3 months and many man hours figuring out how to reclaim it.
Couldn't you brute force it? Like flip the bits until it parses again or something?
At this point, I've forgotten all of the details, but eventually we were able to reconstitute the database and all was saved.
Yeah, this is actually quite fascinating because this is a bit of a weird problem, I admit, that you just described, having all these pickles. But the big data, of course, these days lives in Parquet files, right? And Parquet files, they use something called thrift to encode the metadata inside a Parquet file. And thrift is also a very, very unforgiving encoding. So if a single bit in this thrift encoding goes, good luck getting anything out of that Parquet file because thrift will say no. Without this thrift metadata, you have absolutely no chance of knowing anything about your Parquet file. Of course, you can guess, and sometimes you can reconstruct things but it's super fascinating because I wrote the DuckDB Parquet reader myself. I was so annoyed about this, so I also wrote a thrift reader. It is really fascinating how people prioritized this design of these formats, like thrift. The same also holds for protobuf, for example. They really prioritized saving every little last bit. And they didn't think about the fact that maybe at some day somebody needs to recover this in a hex editor. And maybe we shouldn't save every single bit. Maybe we should throw in like a marker here and there, just put an end marker at something. Or they kind of conflate, for example, in thrift, they conflate, the field ID, and the type on the field ID is in 1 byte, because obviously we can't have 2 bytes, we have to have 1 byte. And obviously, correctly, yes, the field ID is sometimes short, and sometimes the type ID is always short, so hey, let's put them in 1 byte. But what this means is that you just get this crazy opaque bit stream that you have really little chances of recovering. I think there's actually a startup there. This one is for free, like Parquet, forensics. This is really, I have some experience, but I think you can ask arbitrary amounts of money for this kind of services.
That's hilarious. Yeah. It also puts me in mind of early in my career working at a startup that was dealing with some IoT equipment that had its own custom hardware and custom packet format. And the whole hardware and packet format was designed and built by a vendor. And we were trying to build the next generation of hardware and remember what the actual packet structure was and starting to pick apart the individual bit fields of this packet to be able to understand what the messages are supposed to be so we can throw it into a database.
That's juicy.
Yeah. An interesting time.
Yeah, this is formats, encodings. I do love it, though. I have to admit, this is like digging around on the bits until you figured it out.
Yeah. On that note, I'm wondering if you can describe a bit about how DuckDB itself is implemented and some of the architectural details and some of the ways that the design and goals of the project have changed or evolved from when you first started working on it.
Yeah, DuckDB uses something called a vectorized query processor. That is one of the leading sort of designs right now for OLAP engines. There's two. There's the just-in-time compilation camp, and then there's the vectorized query processing camp. Briefly, what the JIT people do is they take the query, they throw it into LLVM, out comes a binary, they run the binary. What we do in DuckDB is we have an interpreter and not a compiler, which means that we just generate a query plan, which is then interpreted. But the query plan is not interpreted for every single row, as it is in things like Postgres or SQLite, but it is interpreted for what we call vectors of data, which are bigger chunks of data. Something like, for example, right now the default is 1024 rows per chunk. And what that does is it amortizes the interpretation overhead versus the execution time of every query operator. And what that leads to is that you decrease the cycles per sort of row processed. That is a metric that we use a lot, and thereby leads to good OLAP performance. You have to imagine DuckDB as a sort of stream of these vector operators. So if you, for example, we had to write a query that says, select some columns from a table where, some condition. You would get these vectorized operators that, for example, first is a table scan. We talked about table scan, can be anything. But in this case, let's assume it runs on our own table format. Table scan have a filter operator. There's an operator that gets one chunk of table at a time, runs its filter, and then moves the resulting vectors of data minus what was filtered out back upstream to the next operator, which might then be a projection, which then throws away some of the columns that are not needed anymore. This is a simplification. In reality, things are more complex. For example, the filter will be pushed into storage that contain things we don't want, but that's in principle how it works. We have operators that operate on vectors. That complicates things a bit sometimes. While this is pretty trivial for things like filters, whether you're running the filter on a single row or 1,000 rows, really doesn't change a lot for your implementation. But if you think about it, if you wanted, for example, to design a aggregate, on a vectorized system, how would you actually do that? And what DuckDB does there is that it has this concept of pipeline. It takes a SQL query, breaks it up into pipelines, and pipelines are things that can be run in sort of a stream of data without having to materialize any intermediate step. And obviously, there are things like pipeline breakers, we call them, things like aggregations or joins, where you have to wait for one side to be fully materialized in the pipeline breaker before you can start streaming the other side. And so this happens all automatically, where we basically take your query, separate into pipelines, and then the execution engine will start pushing data through it. The individual operators, they have to deal with the fact that they see data as a vector at a time. And they also have to avoid the temptation of simply running a scalar row-wise interpretation on the vectors. Everything we do has to be vectorized, and that's sometimes a bit complicated from an implementation perspective. But so this is the basic design. This is also what makes it fast. This concept of vectorized query processing was incidentally also something that was developed at CWI by our colleagues, former colleagues, some colleagues still there. But this is what we use in DuckDB. And the reason we use it actually is because DuckDB is supposed to be lightweight. We are like 10 megabyte binary or something like that. And you cannot do that, in my opinion, with JIT engine, because in order to get all the compiler infrastructure there, you're already like at 200 megabyte plus or something like that. So in order to keep the footprint small, we had to go for the vectorized one, but we also think in general that is a more approachable concept, because when you start to auto-generate executable code, you also complicate things like debugging a lot. And that's something that, for us, of course, is also a factor. We want to be an approachable project where it's easy to contribute to. And that means that we also have to try to keep our engine understandable, which is something we spend a lot of time on. So the goals, I don't think the goals have changed a lot. We started out revolutionizing data management. We'll see where we get. But the basic design of the vectorized engine has also not changed. But what we constantly do is we rethink pretty significant chunks of the internals. So my co-founder and longtime collaborator, Mark Rasfeld, he's, for example, rewritten the execution engine 3 or 4 times at this point, because we've written one, and then we realized, this is not going to work because we need parallelism now. And then we realized, but now we actually don't want to use pull-based operators anymore. We want to move to push-based operators. So it was rewritten again. So this can be done transparently from the outside, because the cool thing, of course, about having a SQL engine is that the user gives us a query. The user doesn't give us execution plan. So we can do with that query whatever we want. And one way we keep ourselves sane is by having a monstrous testing suite. So we have millions of queries in our CI. And that is how we can confidently innovate on individual components inside the engine, where the design constantly changes of individual operators, right? I mean, somebody, for example, one of our colleagues has recently rewritten the sorting operator to be able to go out of core, when you're sorting more data than fits in memory, how do you deal with that? So he just ripped out the entire sorting operator, made something new, and that can get done completely transparently from the outside, because at the end, it's a SQL query. The result is correct. CI passes, everyone's happy. This was something that we realized was actually crucial to also enable contributions, because if the CI passes, we know that it can't be that bad, right? So when we're reviewing pull requests and we see, all the tests are green, we also can be quite confident that it doesn't produce anything horrible, which allows us to be a bit more open to pull requests than maybe other projects. Yeah, but I think it's also something that we're going to keep iterating on operators and details of the internals. But it's really a relief that our outside API is mostly fixed. SQL query in, table out. That does take a lot of kind of design space out of the equation and allows you to focus on the details, which if you're writing something from scratch with a new API, you constantly have to deal with this. Also, the changes from the outside, the changes from demands from customers. SQL engines are pretty straightforward in that sense. You don't have to innovate on that level so much. We recently merged a groundbreaking feature that you can have commas at the end of lists of expressions in SQL because people complain.
Yeah, I was going to ask you a little bit about the specific SQL dialect and some of the ways that you've thought about how you interpret the SQL specification and any extensions that you want to provide, given the fact that you are looking to be embedded in other language runtimes and just some of the capabilities that you want to support as far as any sort of customized functions versus pushing that into the language runtime and being able to handle complex data types and things like that.
We have started with a fork of the Postgres parser for DuckDB. So we took something called libpgu query, which is somebody took Postgres' parser, made a separate project. We took that thing and heavily modified it again. But the lineage, if you want, is Postgres' parser. I've forgotten which version it was, but not that old. Which means that we have like exact compatibility with that parser, which is pretty great because lots of scripts generate Postgres compatible SQL queries. That is like the one side of which dialect it's Postgres, right? Although since we've modified the parser anyway and refactored it and made it compile in C++ and use exceptions and all these things, we've also added things to it. So for example, I've mentioned this joke feature kind of allowing commas at the end of expression lists is something that we can do because we've been through this parser so many times, we can do it. The language interface with functions, indeed, that is also something that is extremely fascinating in in-process database engines, is because a function, a user-defined function, traditionally is something that you define in some horrid PL SQL dialect or something like that, or maybe if you're lucky, the thing will let you write JavaScript or something like that. But in our case is, for example, in the C++ API, a UDF is just a function pointer, right? Because we're in the same memory space. You can give us a function pointer. You use that name in your query, and it will call your function with the data. Very fascinating concept. And basically, it will, arbitrary code, whatever you want. I would say this is still something that we're working on a lot, where I expect to see some more capabilities in the future. But we're working on mapping that to the target languages. I think for Python, we have some initial UDF support for map queries, where it's like, here's a table, .map now this function to every row. And that will create one of these user-defined functions from whatever Python function you give it. We are also working on something similar for R, where we are working on scalar functions. UDF support for scalar functions also in the WebAssembly version of DuckDB and also in the Node version. By the way, the WebAssembly version is wild. I'm not sure if have you seen this?
I think I had noticed that there was a WebAssembly option for using DuckDB, but I didn't dig too much into it.
Yeah, this is something that was super surprising to us because it's something that somebody else, in this case, Andre Cohn from Munich, came up with. Because DuckDB is just written in C++ and has no external dependencies, you can totally throw it into this mscripten thing and run it in the browser. And that is also one of these things that when I first saw it, it was really unbelievable because I thought, no way, you've just taken our many hundred thousands of lines of C++ code and made it one of these browser things. But this he did, and we actually have a demo, I think it's console.duckdb.org, where you can kind of just play with this in the browser, and it's the entire thing, running the browser, including like Parquet support and the whole thing. And you think, why would somebody want to do that? But then I saw a demo that completely blew my mind where, the usual lag was just gone. You had like a dashboard and you clicked around and, your brain expects that there's a lag because it has to go back to the server and do some callback thing and then return the result and yada, yada, yada. But that was just not there. It was just like click, and before you kind of, your finger came up again, it was already re-rendered. It was totally mind-blowing. So I think this is something that I hope we're going to see a bit more sort of usage of is this WebAssembly version, because it's literally mind-blowing.
That's definitely pretty wild. And on that note, because of the fact that it is in process, because it does unlock these additional performance capabilities and the SQL dialect on data analysis in all these different contexts, I'm wondering what you see as some of the common workflows or applications of DuckDB in analytical projects or its use in data pipelines that data engineers might build, and just some of the types of libraries or tools or systems that it might replace in the context of these workflows or projects or team environments.
Yeah, what's the workflow of incorporating DuckDB? I mean, I've briefly said it. You can do pip install DuckDB and you have it. I think very often it is literally 2 lines of code and you're up and running SQL queries on your data frames or whatever you have. And this also is, I think, powered by the fact that we do read a lot of stuff natively already, and we try for every target language basically be able to read the most common table formats that exist in that target environment. So if you're like in Python or in R, you would typically just include the package that is a pre-built version of DuckDB, contains all of it, like from SQL down to storage, and just start using it, for example, to run on your data frames directly. With SQL queries, although we also have a way of you building plans directly, we call this the relational API, where you can do something like dot filter, dot project, dot aggregate, and so on and so forth, right? If you program this, is nicer than concatenating strings to make SQL queries, in my opinion. What we also see, there's people building bigger things around DuckDB that are using parts of it, right? Because nobody forces you to, for example, use DuckDB's front end. You can also directly construct DuckDB query plans and execute them. Some people do that. Other people do only use our front end and have us take the query in SQL, then transform that to a query plan, and then execute that themselves. There's people that only use the Parquet reader. There's people that only use the parser. There's people that only use storage. It's kind of an interesting thing that, there's this kind of standard use case of saying, here, just take the pre-built kind of package as it comes and use it basically as packaged. But there's also a lot of use cases where we see that for bigger deployments, where people just mix and match, they say, okay, I'm actually going to use Arrow to do this, and I'm going to use DuckDB to do that, and then I'm going to pipe this all to some other, to TensorFlow, something like that. It's pretty fascinating. So I think the easiest way to start is just with these Python packages and the R package, or the R package or any other of the packages. Put it in the project, start using the existing APIs. If you think that you need some sort of deeper sort of way into digging into, or you only need parts of the thing and you want to hook into one of the APIs directly, then make use of some of the data structures directly. That is very possible. And if it's not possible, we want to hear about it, because it's one of our stated design goals. And it's also something that we do work with people with, right? For example, there's this company called Stoic that is building a data analysis back on top of DuckDB, also using the WASM version, for example. We have been working a lot with them on, basically extending things that weren't there yet, or they realized they wanted to have a hook here, so we added a hook there. Something we do sometimes. And what are the tools that DuckDB might replace? So I'm teaching some courses on big data every now and then, actually tomorrow again. And one thing I've always kind of found very strange is how hard it was to use these tools like Spark. Have you ever tried to install Spark?
I have not had to do that myself, but I've definitely heard accounts of some of the challenges that it poses, and actually had an interview with somebody who their whole business was around making Spark run in Kubernetes.
Hooray, yet another layer. But I don't know. I feel that we are using a lot of infrastructure. It's as if you drive a dump truck around as your daily driver. That doesn't make no sense. While Spark has its place, I don't doubt that. I also think it's complete overkill in like 99% of the use cases it's used for. We had this fun experiment where we ran some query in New York taxi data set, the standard whatever million taxi rides, yada, yada, yada. And we ran it DuckDB on a single node on Amazon. And then we ran the same queries with Spark on the same node type. But then we measured how many nodes do we have to add in order to beat the performance of DuckDB with that. Any guesses?
So one node of DuckDB, I'm going to say 32 nodes of Spark.
Very good. Did you look at my slides?
I did not.
That's a very good guess. I think it was 32, actually. And
That is a good guess.
Yeah. I mean, I went up in powers of 2. You probably guessed that one, but this was completely crazy. And so also, if we have a planet to protect, I mean, you cannot really justify using 32 boxes when you don't need to, right? I think it's my hope that we will stop using these infrastructures that are built for something else, for another dimension of data problems on really small scale stuff. Another example that is really annoying is you have these, company X installs Spark cluster, right? Has 100 machines. They have 100 employees. Now they have to start doing some sort of load sharing scheme on their Spark cluster, which basically means everybody gets one box on average. Why not just give every employee a virtual machine that runs DuckDB and save yourself a whole lot of hassle? It's my hope that DuckDB would replace a lot of these needlessly distributed infrastructures. I know this is not the most, let's say, hardware vendor friendly thing to say. It's also not the most cloud provider friendly thing to say, but I don't know. This would be one thing that I would hope it would replace. On the lower end, I think I also would like to see use cases that don't belong in transactional systems to move towards DuckDB. For example, people use Postgres a lot for OLAP use cases. People use SQLite, in fact, also for OLAP use cases. I think it will eventually get to the point where that is something that happens in DuckDB because it's just better suited for it. Fun fact, the creator of SQLite has been sending people our way for a while now. When somebody pestering him too much about analytical performance, apparently he says, just go use DuckDB. It's just kind of,
That's great.
Thank you. So that's, I think, where I see this going from both sides. Like we take the tasks that don't belong on Spark or other distributed systems, and we will also take the tasks that don't belong on transactional systems on single node, and we'll just supercharge basically the capabilities of single node, because I think people don't realize is how much you can actually do on a modern laptop, because when do people start using Spark? It's when Panda stops working for them usually, right?
Yeah.
But there is a huge amount of headroom between where Panda stops working or where R stops working, where you actually need to use, something else. I would say that's at least 2-3 orders of magnitude on top of that, probably more. And I think that's also where we want to be.
Absolutely. RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. In terms of the project itself, I know that it's open source and also that you recently formed DuckDB Labs as a corporate entity to help support its ongoing development and provide some additional capabilities around the project. So I'm wondering if you can talk to the governance model of the open source project, some of the long-term sustainability goals, and some of the ways that you think about the boundaries between the open source project and the commercial entity that is helping to support it.
That is an excellent question. It's something we spend quite a lot of time on as well. Sort of there's DuckDB, the project, the open source project, and there's DuckDB Labs, the company, as you said. We have similar logos, but different colors. Let me start with the project. The project itself is governed by the DuckDB Foundation, which is in the Netherlands, which is a non-profit foundation here that holds the IP that makes for an MIT licensed project, but it holds the intellectual property in the project. It also has all the rights in it, and it is merely there to basically perpetuate DuckDB. The foundation collects donations from commercial users of DuckDB, and we're very happy that we've already managed to attract a couple of sponsors. With this money that we get from our sponsors, we basically help fund the development of the open source DuckDB in the sense of that, there needs to be maintenance, bugs need to be fixed. And that is also a global roadmap that we discuss with our sponsors. Basically, if you become a donor to the DuckDB Foundation, we discuss our roadmap for the open source DuckDB with you, and your input is heard. And the money that is given is also used to fund this roadmap, to execute this roadmap. So that's really purposefully disconnected from the company. We have no way of interfering with this, even if we wanted to. It's in the statutes of the foundation that the DuckDB project needs to stay open source, MIT license, so we cannot just change that. And that was done, to protect the project from the company, from us, which is weird, but I feel it's necessary. So DuckDB Labs is a commercial company that provides, let's say, in-depth, professional support for DuckDB itself. So if you're betting the farm on DuckDB, you might want to have a way of getting stuff fixed quickly. So that's kind of how that works, right? And we have a couple of strategic partners for DuckDB Labs, not very many, but people that are really invested in using DuckDB for their, purposes, that basically contract with us, sometimes for custom development around DuckDB. Sometimes they want us to prioritize things. Sometimes they want us to add new features. So far, this has been extremely successful in sort of marrying the goals of the open source project together with the things, our customers want. So we haven't had to make evil trade-offs yet. So I'm quite happy about that. These are separate entities and they have separate goals. And I think it's important, to separate those, because the company can go anywhere. The company might do anything, but we would like the project to be independent of the fate of the company.
In terms of the applications of DuckDB, you've already shared some pretty interesting and wild use cases for it. I'm wondering, what are some of the other interesting or innovative or unexpected ways that you've seen it applied?
We've seen a lot of funky things. So there was somebody that built a big data cluster using iPhones, which was okay. Yeah, so basically just glued together a bunch of iPhones that ran DuckDB and used that to do large-scale data processing. Why, I'm not entirely sure, but I thought it was very funny. There was one project that I was really impressed by, where actually somebody works with us. He managed to port DuckDB to run on the Intel XGX trusted compute thing. So you could actually run SQL queries inside this hardware enclave thing. As I've mentioned, the Vasen module was also something where I'm just blown away what people have done with DuckDB. On the other edge of the scale, we're talking with people that are building giant, cloud infrastructure using our, puny little project as their building blocks. And that's also sometimes very interesting to see. Yeah, we should probably be better at collecting these stories. But what really makes me happy is, remember I said that DuckDB was kind of born out of these discussions with data scientists not being able to do what they wanted to do. And what really makes me happy when I see somebody on Twitter saying, wow, this was not possible before, but thanks to DuckDB is now possible. And this is usually some totally random thing like, oh, here is this giant Parquet file, or here is this, some CSV thing, or just some capability they were lacking before that they now have. That really makes me happy to see that. I want to say lambdas. So people have, lambda functions, right? In cloud lambdas. And it's another one of these things. If you realize that the SQL engine is no longer bound anywhere because you can just pull up wherever you want, you totally can pull up DuckDB in lambdas, and people do. So you can say, hey, I have a lambda that's reacting on some Parquet file uploaded to folder that then runs a query on this Parquet file and writes another Parquet file to this other location. You can actually build an entire query tree out of that. And so we've seen people that have been building Lambda-based query processing engines, which I think was also pretty cool. It's just really impressive. And GitHub shows you sometimes which projects depend on your project. Sometimes I look at that. It's also just really curious. And I also sometimes look at the people that start DuckDB just to see which companies are using DuckDB. You want to know. And it's also really crazy because I think at this point, we have seen everyone. It's really crazy. It's also a bit because it's so inobtrusive, you can just start with a single person, even in a company, and then slowly grow. You don't have to go golfing with the CEO yet.
Absolutely. In your own experience of working on the DuckDB project and working with the community and helping to run this business around it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I'm an academic, as you know, from my background. And obviously, we are used to know everything. And I thought I had a pretty good grasp of SQL, let's say, before we started DuckDB. It turns out I was wrong. I think that it's extremely humbling to see what you can actually do with SQL. That's one thing that was challenging sometimes. For example, Mark spent an enormous amount of time on subquery folding, where, SQL subqueries is one of these most challenging things in the world. I have spent an enormous amount of time on window functions, which is something that most people have probably not heard of. If in your SQL query, you want to have, for example, an aggregate value, but you don't want to actually do an aggregation, but you want to have a scalar function, returns the aggregate. Okay, that sounds weird. It is weird. It's called a window function, and it's usually recognizable by this over clause. It's over and then some thing in a bracket. Okay, that sounds pretty benign, doesn't it? But it turns out evaluating window functions is this endless well of complexity that, basically it's not only a pipeline breaker, which means it needs to fully materialize the input and then do weird things to it, but it's also the only SQL operator that has a notion of locality, which means that you can look up and down in the table, and that breaks all your previous assumptions about, how you can actually rethink the execution of a SQL operator, because the window operator just is different. You have to make special considerations for it. Making the thing fast is also really a nightmare because, again, they have so many ways of executing those window functions that, the traditional SQL way of saying there's 3 ways of doing it, we'll make all those fast and we're done, simply doesn't work. So that was also something that I was really surprised by, is the complexity of seemingly benign things in SQL, that also the technical complexity of making these things run and making them run fast, of course, which is our added problem, right? We can't just pull a Postgres and implement it in whatever way, but we have to actually think about it, how we can execute this quickly. And we have to make it work in a vectorized engine, which, as I mentioned before, sometimes throws additional architectural complexities at you. So that was really, I would say, humbling, how much we didn't know. And also to see, where the real problems are, And I think that also is something that sets us apart, because we're an open source project. We get a lot of feedback, and we're super thankful because we learn so much about how people actually use databases that you will not find in any textbook, that you will not, the Oracle people will have never heard of this, because the people that do that don't have 10 million sitting around to pay them. So that was also super interesting and also super humbling to see how people use databases and then how things go wrong, because they're holding it wrong, but obviously not holding it wrong. Your assumption of how they should hold it is wrong. So you have to basically make the handle like pink so they kind of see it and hold it correctly. But this is really difficult if your interface is a SQL API, right? I mean, how do you give people hints in SQL queries? Difficult. So this was really interesting to see. And then every day, as I said, every day we see interesting things people do with it. And what I generally think was the most unexpected thing is that people cared about this thing in the first place. That's something I still can scarcely believe, that, we made this thing. And yes, as I mentioned, we did talk to some people and we thought, okay, if they care about this, then probably other people care about this. But I am quite impressed about the adoption, and it's of course a big responsibility. Whenever we make a release, we have to actually be sure. But that people cared really surprised me a lot. So I would like to say thank you.
And for people who are interested in the capabilities of DuckDB and they want to be able to have this easy on-ramp, quick access to performance SQL queries, what are the cases where it's the wrong choice and maybe they are better suited with running a 32-node Spark cluster or putting it into a Snowflake or a Teradata or using some other approach to managing these data analyses and manipulation?
Yeah, I think we've briefly had this. If you have many, many concurrent users on a data set that is, centrally managed, you probably want to use a traditional data warehouse. When would you go for more the Spark sort of kind of way? Yeah, this is of course the big question, is like, how big should the data be? if you have petabytes of data sitting around, I would say probably you don't want to use DuckDB on that yet. But if you have the 32-node Spark cluster, I mean, actually, you should never use a 32-node Spark cluster. You should use a 1,000-node Spark cluster, or don't, I think there's no good reason to have these mini clusters around, because you're getting like all the pain of running clusters. And basically, as I've explained to you with this example that we did, all the computers is basically eaten up by the coordination that is designed to deal with a 1,000-node cluster, right? So why anybody would not run a 1,000-node cluster is beyond me. Does it make sense to you? I mean, why would you have a small cluster?
That makes perfect sense. And yeah, there's definitely a lot of just kind of cargo culting of, oh, we use Spark because everybody uses Spark and that's the thing that you use Spark for.
Yeah. And then, they're in Python and then they make a computation with Spark and then they say, but now I want to use matplotlib. And it's like, yeah, no, because you have to now forget about it, because in order to pull this from Spark to your Python shell, Spark, in its infinite wisdom, serializes this data using the Hive protocol, which I've written a paper about. And the Hive protocol uses Thrift to encode column data, which is not a good idea, probably. And which means that actually to pull something from your 1,000-node Spark cluster that is not that crazy big, let's say 2 gigabytes or something like that, you pull that into your Python. Maybe you even want to use learning on that. Who knows, these days. In order to do that, you're going to spend the vast majority of time that this query takes end to end, because the 1,000 nodes were done quickly running your extract or whatever it is on some Parquet files. But then pulling the result into your Python shell is going to take, hours. Where you could also say, hey, if I run this query in DuckDB, it's already in the correct memory. So I can just do whoop, and it's there. I think there was a tweet some time ago. It's like where somebody said, okay, time to produce query result in Postgres, 0.1 milliseconds. Time to construct SQL Alchemy result set, 2 seconds. I think that's more true than people want to believe.
Absolutely.
How much performance we leave on the table.
I think we've touched on this a little bit, but in terms of the near to medium term future for DuckDB, what are some of the projects that you're focused on, or new capabilities that you're looking to add, or areas that you're excited to dig into? And given that it's open source, any areas of contribution that you're looking for help with?
We do love contributions. We really do. And I think we've also tried to make a welcoming community on our Discord and our GitHub. I can maybe go through the strategic directions for the project itself, so that people get an idea of what would be contributions we would value. Of course, we value all the contributions. There's issues that we have a lot of open tickets on GitHub that some of them are tagged with good first issue. People want to get started. That's a great place to start. But in terms of the more general directions that we want to go into, I think the one big one right now is the out-of-core capability for all operators. I think this is important. We call this the Galaxy Quest principle. Never give up, never surrender, because we want to be able to complete queries if at all possible, right? And that sometimes means you have to go out of memory, in the sense that I mentioned this before, you have these pipelines, and sometimes you have pipeline breaker operators that need to materialize some input, like a sort, needs to see all the input before it can sort, okay? And these operators, they might need a lot of memory. If you build a join hash table on a table that has a terabyte, then this might take a terabyte of join hash table. That's not great. Probably don't have a terabyte of memory. So we're constantly focusing a lot on teaching every single one of our operators, and we have like 20 of them, how to gracefully start using disk space instead of memory if possible, if we run out of memory. And this is only so we can make sure we can always complete queries. So this is a big focus, and we're working on that. We've been looking at a bunch of operators already, much to be done. It's also really fun to think about that, how to do this in a dynamic way. That's one thing. Another thing is that, remember we talked about our storage format, the hashes of the blocks in order to... hashes of blocks sounds familiar, doesn't it? The hashes of blocks that protect against the bit flips on disk or disk corruptions. This is also something that the storage format is something we want to finalize this year if possible, because it's kind of what keeping us from releasing a 1.0. Because we want to not make a backwards incompatible change to the on-disk storage format again after releasing the 1.0. It's our goal. We'll see whether we manage. And right now, there's just too much going on in order to guarantee that. So we want to stabilize the storage format so we don't break backwards compatibility with existing database files anymore. Mind you, Postgres doesn't guarantee that, right? This is something that normal database systems don't do, right? In Postgres, I think they guarantee compatibility within the same major version, but that's it. What we try to do is something more akin to SQLite, where they say anything that has been created with any SQLite version bigger than 3.0 is still readable and writable by current SQLite versions. I think that's also a bit far, but we would at least want to have the backwards compatibility there going. So that's a big topic. We're also actively working on compressed storage. So DuckDB will automatically analyze the tables on disk during checkpointing to see which compression method would be most applicable per each row group. So row groups are like subsets of tables that we store individually. We run for every column, and we run this analyze phase during checkpointing to see which compression method is most applicable and then apply that method. We have built a framework. We've built a bunch of compression methods, but we have to do more there. So we want to finalize that. We want to add more compression methods. Also, maybe a good way to getting started, implement a compression method, because also they're pluggable. These are also user pluggable. That's pretty cool. If you know better than us how to compress your data, sure, write your own compressor. Why not? We are generally also working on performance engineering, of course. While DuckDB is already pretty fast, there's always some edges where we need to improve. And for anyone interested in low-level C++ hacking, to make things go fast is also something that we enjoy. And if you enjoy that kind of thing, maybe we should work together then. And these are, I think, some main directions. And then we also have the whole testing area. We want to do more in terms of destructive testing as well, in the sense of, defending against misbehaving disks, misbehaving memory, and then integrating all that into the testing framework so that every time, we commit, we will run all our tests also on some simulated memory. That might also be fun for people to look into. So these kind of things. But I would say that's the main directions that we want to go into. I want to go continue for the main project. And obviously there are some more sort of domain specific things like some people are interested to work on geographical data type support for DuckDB. We haven't done anything yet. Some people are working on making more graph-like use cases work on DuckDB. We'll see what comes out of there. But I'm really excited to see a lot of things springing up left and right. And we also have worked really hard to make an extension API. So DuckDB has this plugin support where you can change a lot of things about, which types, which functions, and so on are available in the systems simply by loading plugins. Also very similar to SQLite, which is where we copied it from. And that, I think, also would allow for lots of these things to live on their own. For example, imagine DuckGIS or something like this, similar to PostGIS, which is just a plugin, that doesn't actually have to change anything in the base system. I think that would be really interesting.
Are there any other aspects of the DuckDB project or the applications of OLAP capabilities in process, in language ecosystems, and the work that you're doing at DuckDB Labs that we didn't discuss yet that you would like to cover before we close out the show?
It's really been a privilege to work with everyone on DuckDB because, it's a big project, let's say a big undertaking. And I'm really, really thankful for everyone that has contributed and is contributing, because it would not be possible without them.
All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as my final question, I'd be interested to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
It's very interesting because I think the design of DuckDB was kind of motivated by one of these gaps, right? So, okay, there was no in-process OLAP system yet, so we made one. And there are many of these things. For example, we can throw out some startup ideas, right? For example, I think strings in data management systems, like text, is still one of these huge unsolved things where, yes, they work in principle, but it's just painful. It's bad performance. It's, inefficient storage. The whole, we have done this experiment where we took a benchmark like TPCH, right? And converted everything to strings and rerun it on different database systems. It's, orders of magnitude later, you get your query result. That's not great. Somebody should work on that. I think generally the debuggability of data pipelines is pretty bad. Running query engines is something that hasn't mattered traditionally. And it also, in DuckDB, it's not something that I'm particularly proud of, but seeing what's going on while it's going on, I think that's also something that so often we just, we hit a button and then we have to kind of wait and pray that it will finish eventually, but we have no concept how long it will take. Is there progress? Who knows? So I think there's a lot there. But I think similar to the gap that we found, there are a lot of these blatantly obvious, let's say, nightmares, tooling nightmares that are just waiting for somebody to tackle. I would say strings.
All right. Well, thank you very much for taking the time today to join me and share your adventures with DuckDB. It's definitely a very interesting project and obviously a very important and complex undertaking. So I appreciate the time that you and your colleagues have taken to bring this to the world and continue to help improve it and add new capabilities and functionality. So appreciate you taking the time today, and I hope you enjoy the rest of your day.
Thanks so much for having me. I'm really thankful.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.